In section 4.2, we are solving systems of linear equations by substitution. So our learning objective is to use the substitution method to solve a system of linear equations. I've listed here 4 steps in the substitution method. The first is to solve one of the equations for one variable. Step 2 is to substitute the expression from step 1 into the other equation. Step 3 is to solve that equation in step 2. And then step 4 is to use a solution from step 3 and the expression from step 1 to find the solution to the system. Solve each system of equation by the substitution method. Note the following systems have one equation already solved for one variable. So if we go back to the 4 steps in the substitution method, we see that the first step is already done. For example, A. The second equation already has y by itself. So our step number 1 is to solve one of the equations for one variable. That step is done for us. We can write that step 1 as y equals 2x. Now step number 2 is to substitute the expression from step 1 into the other equation. The other equation is x plus y, but instead of the y, we're going to enter what y equals, which is 2x equals 9. So again, we took x plus y equals 9, or x plus 2x equals 9. We're going to do step number 3, which is to solve that equation in step number 2. And we know that x plus 2x is 3x. And if 3x equals 9, when we divide both sides by 3, we do get x is equal to 3. Now, step 4 is to use the solution from step 3 and the expression from step 1 to find the solution to the system. So go back to our answer from step 3 and what we had in step number 1. We're combining those. Since we know that y is equal to 2x and we know that x is equal to 3, we can write this as y is equal to 2 times 3, or y is equal to 6. So our solution to this system of equations can be written as an ordered pair, 3, 6. Now it's always a good idea to check to make sure that this solution works for both of those equations. So let's go back to our original equations and check the point 3, 6. In the first equation we have x plus y equals 9. And if x is 3 and y is 6, we know that that equals 9. So it is a solution to the first equation. We want to check it in the second equation, where y is equal to 2x. If y is equal to 6 and x is equal to 3, we do know that 6 does equal 2 times 3. So we know that that is a solution to the system of equations, and we solve that by using the substitution method. Let's continue with the example for part B. The first step is to solve one of the equations for one variable. That step is already done for us, as we see the first equation is x equals y minus 2. Step number 2 is to take the other equation, which was x plus y equals 6, and we're going to substitute, replace that x with the x from step number 1, and we get y minus 2 plus y equals 6. Step number 3 is to solve that equation. We combine like terms to get 2y minus 2 equals 6. Add 2 to both sides. And we get 2y is equal to 8. And then we divide both sides by 2 to get y equals 4. And now we are ready for step number 4. Step number 4 is where we take the answer from step 3 and the equation from step number 1 and solve for the other variable. When we do that, we get x is equal to y minus 2, where y is equal to 4. So we know x is equal to 4 minus 2, x is equal to 2. So our solution can be written as an ordered pair, 2, 4. And of course, we do want to check that going back to the original equations. We're going to check when x is 2 and y is 4 if that's a solution to both of those equations. For x equals y minus 2, when x is equal to 2 and y is equal to 4, we know 2 does equal 4 minus 2. And x plus y, or 2 plus 4, does equal 6. So we know that this is the solution to that system of equations, and we use the substitution method. Solve each system of equations by the substitution method. Here we need to do all 4 steps. The first step is to solve one of the equations for one variable. You could choose either one. For the first example, I would like to try with the first equation, x plus 6y is equal to 2. And we want to get one of those variables by itself. It would be easier to get the x by itself, and we can do that by subtracting 6y from both sides of the equation, so that we get x is equal to negative 6y plus 2, or you can write it as 2 minus 6y. That's our step number 1. Now step number 2 is to take our answer from step 1 and plug it into the other equation. The other equation is 4x plus 5y is equal to negative 11, and we take the expression that x is equal to negative 6y plus 2, plug it into the x in the second equation. When we do that, we get 4 times negative 6y plus 2 plus 5y equals a negative 11. When we distribute the 4, we get a negative 24y plus 8 plus 5y is equal to negative 11. Now when we combine like terms, the negative 24y plus 5y is a negative 19y plus 8 is equal to negative 11. We're going to subtract 8 from both sides to get y by itself. This is step number 3. And there we get negative 19y is equal to negative 19, so that means y is equal to 1. Our next step, that was step number 3, is to solve that equation. And step number 4 is to use a solution from step 3 in the expression in step 1 to solve for the other variable. Since we know from step number 1 that x is equal to negative 6y plus 2, and we just found out that y is equal to 1, then we can solve this equation to get x is equal to negative 6 times 1 plus 2, or negative 6 plus 2 is negative 4. So our solution to this system of equations, x comma y, is negative 4 for x and 1 for y. As always, we do want to check our work by plugging those values back into the original equations. Of x plus 6y, that would be negative 4 plus 6 times 1, that does equal 2, we can check that. And into the second equation, 4 times negative 4 plus 5 times 1, that's 4 times negative 4 is negative 16 plus 5, that does equal a negative 11, so this is a solution to that system of equations. Let's go on to example D. First step is to solve one of the equations for one variable. We'll begin by taking the first equation, x minus 3y equals 3. We can solve this equation for x by adding 3y to both sides of the equation. When you do that, you get x is equal to 3y plus 3. So that's our step number 1, is to solve one equation for one of the variables. Step number 2 is to plug that equation, or substitute the expression from step 1 into the other equation. So step number 2, we're going to take negative 5x, but instead of that x, we're going to replace it with 3y plus 3 minus 2y equals 2. So I took the second equation here and substituted in x equals 3y plus 3. We can use the distributive property to get negative 15y minus 15 minus 2y equals 2. By combining like terms, we get negative 17y minus 15 equals 2. Then we can add 15 to both sides and get negative 17y is equal to 17. And then by dividing both sides by negative 17, we can show that y is equal to -1. So that is our step number 3. Now step number 4 is to take our answer from step number 3 and the expression from step number 1 to find the other variable. Here we have x is equal to 3y plus 3, where y is equal to -1. And then when we solve this, we have x equals -3 plus 3, which is equal to 0. So our solution, x comma y, is 0 comma -1. As always, we want to check our work by plugging in 0 for x in the first equation and -1 for y. And we do see that -3 times -1 is a +3. We also substitute it into the second equation. -5 times 0 minus 2 times -1 does equal 2. So we know 0, -1 is the solution to that system of equations. Let's continue. Solve these systems of equations using the substitution method. Again, our very first step is to take the one equation, solve for one variable. I'm going to begin with the first equation and get the x by itself. I do that by adding 4y to both sides. And then we see that x is equal to 4y minus 1. Step number 2 is to substitute the result from step number 1 into the other equation. So the other equation is 6x minus 3y. Well, I'm going to replace that x with 4y minus 1. Minus 3y equals -6. Using the distributive property, I get 24y minus 6 minus 3y equals -6. By combining like terms, I get 21y minus 6 is equal to -6. Then I'm going to be adding 6 to both sides of the equation, and the result is 21y is equal to 0. By dividing both sides by 21, we see that y is equal to 0. That is our step number 3. And then we're going to plug that into the answer for step number 1, where x is equal to 4y minus 1, or y is equal to 0. So that means x is equal to -1. Our solution to this system of equations is -1, 0. As always, check your work. Plugging in -1 for x and 0 for y, we get -1 minus 4 times 0 does equal -1. And 6 times -1 minus 3 times 0 does equal -6. So we know that -1, 0 is a solution to that system of equations. Let's go to the next example. 6x plus 7y equals 33 and 3x minus 3y equals -42. You can begin with either one of these equations. Looks like the second equation is a little bit easier than the first one, so I'm going to write my 3x minus 3y equals -42, and I want to get one of those variables by itself. Let's say we get the x by itself. To do that, we add 3y to both sides of the equation, and then we get 3x is equal to 3y minus 42, and then we're going to divide both sides of the equation by 3. To get x equals y, you want to divide both of those by 3, minus now that is what we get for step number 1. Step number 2 is we're going to take the result from step number 1 and plug it into the other equation. Since we use the second equation, we've got to plug it into the first equation. 6 times x, but I'm going to replace x with y minus 14, plus 7y is equal to 33. Using the distributive property, I get 6y minus 84 plus 7y is equal to 33. I'm going to combine like terms to get 13y minus 84 equals 33. Now we add 84 to both sides, and that will give me 13y equals 117. And now we divide by 13 to get y is equal to 9. So that is our step number 3. to solve that equation for y equals 9. And now in step number 4, we're going to put that answer that we get in step number 3, and we're going to plug it into the result from step number 1. So we know that x equals y minus 14, so x equals 9 minus 14. So that means x is equal to negative 5. Our solution to this system of equations is negative 5, 9. And we want to check to make sure that is a solution to both of those original equations. We know that 6 times negative 5 plus 7 times 9 does equal 33. And we know 3 times negative 5 minus 3 times 9 does equal negative 42. So negative 5, 9 is a solution to that system of equations. Okay, let's solve example G. We're going to take one of those equations and solve for one of the variables. I'm going to begin with the first equation, 4x minus 3y equals 30 plus x. And I want to get, let's say we get the y by itself. We do that by subtracting 4x from both sides of the equation. And I get a negative 3y equals, I have 1x plus a negative 4x, that's going to be a negative 3x plus 30. Now I can divide both sides of the equation by a negative 3 to get y equals, negative 3 divided by 3 is 1x minus 10. So that is our step number 1, solve one of those equations for one of the variables. Now we're going to plug that into the other equation in step number 2. We have 4x on the left side of the second equation equals a negative quantity y, just x minus 10 plus 2, and then plus 3x. We want to simplify this equation. We'll begin by distributing that negative and then combining like terms. And we get 4x on the left is equal to negative x plus 10 minus 2 plus 3x. By combining like terms, we get 4x equals 2x plus 8. And then we can subtract 2x from both sides to get 2x equals 8, or x is equal to 4. So that is our step number 3, is to solve that equation for x. Now our step number 4 is to take the answer from step 3 and the result from step 1 to find the other variable. So we know y is equal to x minus 10. If x is 4, 4 minus 10, so y is equal to negative 6. Our solution to the system of equations is 4, negative 6. Again, as always, you want to take the time to check to make sure. You can double check these on your own and find that 4 times 4, where x is 4, minus 3 times negative 6 will equal 30 plus x, or 30 plus 4. And the second equation, 4 times 4, is going to equal negative y, just negative 6 plus 2, plus 3 times 4. So take a minute, you can double check those, and we'll find that this is a solution to both of those equations. So it is a solution to the system of equations. For the next example, I noticed that I have fractions in the second equation. It may be easier to work with an equation without fractions, and that can be done by taking that equation 1/2 x plus 1/2 y equals negative 3. I'm going to multiply both sides of the entire equation by that common denominator of 2. That is going to simplify this equation so that when we distribute here, 2 times a 1/2 is 1, or just x, and then 2 times a 1/2 y is y, and on the right side of the equation, negative 3 times 2 is negative 6. So we have our the second equation is now in much simpler form, and we can solve for one of the variables there. Let's solve for x by subtracting y from both sides of the equation, and then we get x is equal to negative y minus 6. So that's our step number 1. Now step number 2 is to take the result from step 1 and plug it into the other equation. The other equation is x minus y equals negative 4. So I'm going to replace the x with a negative y minus 6 minus y equals negative 4. And then I'm going to simplify this by combining like terms to get negative 2y minus 6 equals negative 4. Going to add 6 to both sides to get negative 2y equals 2. And then by dividing both sides by negative 2, I get y equals a negative 1. That's our step number 3. Now I'm going to plug that into the result from step number 3 and the result from step number 1. I'm going to solve that to get the other variable. We know that x is equal to negative y minus 6, or negative 1 minus 6, and that is the same thing as 1 minus 6, or negative 5. So x is equal to negative 5, y is equal to negative 1, so our solution can be written as an ordered pair, negative 5, negative 1. And you want to check your solution here. X minus y equals negative 4 is, when you substitute, you get negative 5 minus a negative 1 does equal a negative 4, because that minus a negative becomes a positive. And 1/2 of negative 5 plus 1/2 of negative 1 does equal negative 3. That's negative 5 over 2 minus 1 over 2, or negative 6 over 2, which is negative 3. So we find that negative 5, negative 1 is a solution to that system of equations. Let's solve the next system of equations. We'll begin with taking the first equation, 4x plus y equals 11, and we'll solve this for y by subtracting 4x from both sides. Then we get y is equal to negative 4x plus 11. That's our first step in the substitution method for solving systems of equations. In step number 2, we're taking the other equation, 12x plus 3y, but we're replacing that y with negative 4x plus 11 equals 33. Now we can use the distributive property, and we get 12x plus a negative 12x plus 33 is equal to 33. When you simplify this equation, 12x and this negative 12x is 0x, and what we end up with is 33 equals 33. We no longer have any variables. Since this is a true statement, this is a special case of a system of equations. And in this case, if we end up with an equation with no variables at all, we have an infinite number of solutions, and the two graphs of those linear equations are the same line. So that means there's an infinite number of intersection points. So if you were to graph these, it would look something like this is the first line, and then this is the second line, and there would be an infinite number of intersection points. So this is a special case, an infinite number of solutions. One way to write all of those solutions, since it's possible to write an infinite number of points, we can write it using set notation, where the solution is all the points x, y, such that the equation is true, and we can say that 4x plus y is equal to 11. That's one way of writing it. You can also say there's an infinite number of solutions. The graphs are the same line. Okay, let's continue. Solving the next example, we take one of those equations and solve for one of the variables. I'm going to take the second equation. It looks a little bit easier. 5x plus 20y is equal to 0. I'm going to subtract 20y from both sides of the equation to get 5x equals negative 20y, and then I'm going to divide by 5 to get x by itself, and I get x is equal to negative 4y. So that's the first step in solving a system of equations using the substitution method. Take one of those equations and solve for one of the variables. Now I'm going to plug that into the other equation that we didn't use, the first one, negative 6x, or negative 6 times negative 4y, minus 24y is equal to negative 10. Let's simplify this equation, and we get 24y minus 24y equals negative 10. But notice what happens when we simplify the left side of the equation. 24y minus 24y is 0 on the left side, and on the right side we get negative 10. Now 0 does certainly not equal negative 10. So this means that we have another special case, but it can never be true that any value of y you would end up with 0 equals a negative 10. So in this case, there are no solutions. There's absolutely no solution to the system of equations. That means the lines are parallel. That means they will not intersect. So if you were graphing these lines, they would look very much like perhaps something like this and something like this. You would see that those two lines would be parallel. They would never intersect. So we say that there is no solution. Another way to write that is to draw a 0 with a line through it. That's another way of saying no solution.